Hey everybody, I'm coming to you from the Hampton Inn and Suites in lovely downtown Hazard. Probably not really downtown, but I'm in Hazard. So, yeah, it's Valentine's Day, and I am here alone. Stephen has an academic tournament tomorrow, so we decided not to drive back home. And my wife can't be here because she is taking care of our dogs, and we just had two goats born today, so she's busy taking care of the little animals. So, what else am I going to do with my time other than maybe do a little bit of math with you all and make this video to get to you for the probability basics. So, when I handed you guys the notes today, I told you this is pretty straightforward, fairly simple. Nothing that you guys probably really aren't too familiar with already. But I'm going to go through these notes real quick and get you guys on track to be ready for your exam next week. So we'll go ahead and start with the first thing right here with example one. It's we've seen this example before. It's the top 5 officials in the state of Kentucky: the governor, lieutenant governor, secretary of state, attorney general, and treasurer. It says find the probability that we obtain the governor and treasurer when we take a simple random sample of 2 officials from the group. So I've already written down all the possible combinations of 2 officials. And if you notice, we have 10 possibilities. So for part A, it says find the probability that we obtain the governor and the treasurer. So governor and treasurer only occurs one time out of the 10, and so that's your probability. It's 1 out of 10, or 1/10, which is also the same as 0.10. Part B, find the probability that the Attorney General is included in the sample. So we need to just find all the possible combinations of 2 officials where the Attorney General is listed. So there's 1, 2, 3, 4. So we have 4 possible combinations out of 10. So there's a 4 in 10 chance that we're going to have the Attorney General as our chosen official, or in one of those groups, which would give us a probability of 4 out of 10, or 0.40. So pretty straightforward. I think this is something that all of you are at least somewhat familiar with. Probability for equally likely outcomes. So right now everything we're dealing with is an equally likely to occur outcome. N is going to be the number of possible outcomes, and then this little f is the event that we're looking at. What is the probability of that event occurring? Example 2 uses a distribution table for annual income of U.S. families, and we can still use the same information here to come up with probability distributions or probability values. I want you to notice that our N is the 78,867. So part A says find the probability that a selected family has an income between 50,000 and 74,999. That is going to be this row in our table. So that one is pretty easy to answer. Part A is 15,000 out of 78,867. And if we take that down to a decimal for the probability, let's see, it's 70. You think I could use a calculator? It's going to be approximately 0.1901. So about 19% chance that the selected family has an income between 50,000 and 74,999. Part B, that the selected family has an income between 15,000 and 49,999. So that actually will include these 3 values in the table. So we're going to add up the numbers there on the right hand column. So we have 7,194 plus 7,863 plus 10,898 and we get 25,955 out of 78,867. And so that probability becomes, let's see, 7867, 0.3291. So about almost a 33% chance that a randomly selected family will have an income between $15,000 and $49,999. Then the final part of this is part C. It says what's the probability that a randomly chosen family has a income under 25,000. So that is going to be these two values from the table. So again, we're going to add the two numbers in the right hand column. And we get 14,021 over 78,867. So as a decimal for the probability, we are going to have 0.1778. So almost 18% chance that a randomly chosen family will have an income less than $25,000. Let's see, dice. Every time you deal with statistics, a lot of statisticians like to use dice and cards as examples for probability. So here are all the possible combinations of two dice being rolled, what you can get as possible outcomes. Part A, find the probability that the sum of the dice is an 11. So the only two ways that can happen is when we have a 5 and a 6. So here's one, and the other alternative is to roll a 6 and a 5, and so there's the other one. So out of 36 outcomes, part A, there is a 2 in 36 chance that we will roll a sum of 11, and if we convert that to a decimal, it's 0.0556. So roughly a 6% chance that when you roll two dice, the sum will come up as 11. Part B, find the probability that doubles are rolled. So there's only 6 possibilities for doubles. We have 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. There's no other doubles. So that's in 6 in 36 chance, or 1/6. And when we convert that to a decimal, we get 0.1667. So about a 17% chance that we will roll doubles when we roll two dice. Let's see, the meaning of probability, you can read through this, but you want to make sure that you understand what we're talking about when we talk about the probability. How do we interpret it? Some examples here. The probability is 0.314 that the gestation period of a woman will exceed 9 months. The probability is 0.667 that the favorite in a horse race will finish in the money, which first, second, or third. And then the other, the probability is 0.40 that a traffic fatality will involve an intoxicated or alcohol impaired driver or non-occupant. So what do we mean when we talk about those things? Well, with the first one, it means just that there's a little bit over 31% chance that a woman will carry a baby beyond 9 months. The second one, there is a 66.7% chance that the favorite horse in a race will finish in the top 3. And then the third probability is that there's a 40% chance that a traffic fatality will involve an intoxicated or alcohol impaired driver or non-occupant. We look at, so here is, these two graphs represent coin tosses. And when we talk about tossing a coin, there's two possibilities. You have heads or tails. And so that means really you have a 50-50 chance. But now you can start flipping these coins and you might end up with 12 heads and 7 tails. That's not 50-50. what this graph shows is the more you repeat that experiment, so the more times we flip the heads, so you can see here, or more time you flip the coins rather. This is two different experiments I used to use random number generator 1 and 2. You can see that as we go further out across the x-axis, the number of times the coin is tossed, the closer we actually get to that proportion where it is 50-50. In the first graph, there are fewer heads than we would expect initially, and then as we move out to the right, it gradually approaches that middle value of 50-50. But actually at 100 tosses, it doesn't quite make it to that point. So maybe if we did 1,000, it would get out to 50-50. In the second graph, you can see it kind of fluctuates going around the 50-50 mark, and it kind of holds there from about 70 tosses on out to 100. So probability just means what we think might happen. It doesn't guarantee it's going to happen. It just means that there's a pretty good chance that this is the way it's going to happen, or the way it will occur. Probability, when we're talking about just the decimal values, the probability of an event is always going to be between 0 and 1. It will never be greater than 1, because that would mean more than 100% chance. And it'll never be less than 0, because we can't have a negative probability. Property 2 is that if the if the event can never occur, if it's impossible for that event to occur, it has a probability of 0. And the probability that event must occur is 1. That means it's certain. We know for a fact that that event will happen. So if we go back to example 3, it says find the probability that the sum of the dice is 1. Well, if you don't even really have to look at the dice here to figure that out. We're rolling 2 dice. The very minimum, our probability, or our sum has to be 2, and then the maximum, our sum has to be 12. We can never roll a 1, a sum of 1, when we have 2 dice that we're rolling together. So for part A, the probability is 0. And then for part B, find the probability of the sum of the dice is 12 or less. Well, so 12 is I'm going to erase these. 12 is the maximum that you can roll. Can't roll anything greater than 12, so that means that everything has to be less than 12. So that is a case where the event is certain. Every single roll of the dice will come up 12 or less. So that probability is 1. That is the end of the section of notes here on probability basics. Like I said, I hope that this was fairly straightforward. You should be able to knock this homework out pretty easy. Question number 1 looks back at example 1. Question 2 is talking about a deck of cards. 3, 4, you're given a couple of different values or tables to look at. So I think this, even though there's 9 problems, and yeah, a couple of them have A, B's, and C's on them, don't freak out. Should go fairly quick. But that's it. That's probability basics. I know you guys are not going to be sitting at home watching this video tonight because you all probably have Valentine's Day plans, unlike yours truly, who is sitting here at the hotel while my wife wrangles baby goats. Hope you guys are going to have a great weekend, and I will see you on Monday. Everybody take care.